Hey guys, Mr. B here. So this is the video lecture for the 9.3 notes. We're going to be going over naming and writing formulas for molecular compounds. So molecular compounds are super easy. Of all of the different compounds we learned about in this chapter, ionic ones, molecular ones, and then acids and bases, moleculars are by far the easiest. The main thing that you want to make sure is because they're so easy, a lot of students a lot of times like to just use them everywhere, right? They like once they learn this system, they just start applying it to like everything, and then they start forgetting the ionic naming system and all that stuff because they just want to use this one on everything because it's so easy. Don't do that, okay? Understand that the molecular naming system is only for molecular compounds, as easy as it is, and as much as you want to use it everywhere, only use it where it's appropriate, okay? Now, the nice thing about the naming system for molecular compounds is you guys are probably familiar with a lot of the pieces of it. So the molecular system deals with prefixes. You guys are used to like milli, like a milligram, or kilo, right, like a kilobyte, or giga, like a gigabyte, or things like that. There's different prefixes that indicate how much of something there is. Now, milli and kilo are metric prefixes. We're not going to use those for this naming system, but prefixes in general like that is how this whole naming system works. Super simple. It should be really quick to go over, and you'll probably get it in like 5 minutes. So, all right, here we go. So, naming binary molecular compounds, okay? Now, remember that binary means two elements, and if they are molecular, that means that the two elements we're dealing with are non-metals only, okay? Most important thing is you need to be able to recognize when you see a molecular compound and when you see an ionic compound. That's by far the biggest thing that students kind of fail at. If you don't know what a molecular compound formula looks like, you have no idea how to name it. And if you think it's the same as an ionic one or you can't tell the difference, you're going to get really confused. So real quick, just to give you some examples, ionic compounds have a metal and a nonmetal. So ionic would be something like aluminum chloride. Okay, aluminum, metal. Chloride or chlorine, nonmetal. That's ionic. Or we could have polyatomic ions in the formula too. So another example might be like, let's go like magnesium phosphate. Okay, so this would be one where, again, we have magnesium, metal, phosphate, which is a polyatomic ion, makes it ionic. Molecular compounds, on the other hand, are nonmetals only. So two nonmetals. So example of this would be like N2O, nitrogen, oxygen, nonmetal, nonmetal, molecular. Another example of this would be like SF6, sulfur, fluorine, or fluoride, nonmetal, nonmetal. Okay, so you first got to be able to determine what a molecular compound looks like from an ionic one, and if you can't tell the difference, then it's really hard to know when you use this naming system. Okay, so that's step one. All right, anyway, moving on. So here's some examples of some molecular compounds. Carbon and oxygen combine to form two different common compounds. Carbon monoxide, CO, and carbon dioxide, CO2. Okay, so by looking at the names, we can kind of see the naming system already at play. Carbon monoxide, mono means one. So carbon monoxide, carbon with one oxygen, versus carbon dioxide, di means two, right? So two oxygens. Now, obviously, these two formulas are very similar, and the names are very similar, but you wouldn't want to get them confused because if you're sitting in a room with a small amounts of CO2, which you are all the time because we breathe out carbon dioxide, so it's all around us all the time. In fact, there, I just added some more. Completely fine, right? It doesn't harm us, it doesn't do anything, or it doesn't harm our body, we make it all the time. But if you're sitting in the room with a small amount of carbon monoxide in the room, you would die of asphyxiation, which is basically you would suffocate very quickly. You'd probably pass out, you get lightheaded, and you'd go into a coma, and eventually your heart would stop and you would die. And this is because carbon monoxide is super poisonous. Most of you probably have a carbon monoxide detector in your house. It's usually a little white thing. It like sticks into an outlet and it sits usually like out in the hallway by your bedroom, most likely, because carbon monoxide poisoning is not super common, but it oftentimes will kill people very quickly because it doesn't smell like anything and you can't see it. And the only way you would know that you have it, like carbon monoxide poisoning, is you probably feel kind of funky or lightheaded, and you don't have a whole lot of time to get out before you're probably going to pass out. So carbon monoxide detectors are pretty much almost mandatory in all homes, just because if there were carbon monoxide in your house, you'd want to get out right away, and that thing will go off and wake you up to tell you, like, get out. So the naming system obviously distinguishes between these two compounds pretty easily. So again, as if you've already noticed, we use prefixes in the names of these molecular compounds to tell you how many atoms of each element are present. Now, these prefixes are not something that is going to be given to you on a test, so you do need to know them. They're not super difficult to remember. Most of them are used in common day language. So mono means one. Maybe you've heard the phrase before, like, let's go mano y mano. That's like, let's go like man to man, like one on one. Di means two. That one maybe you're not as familiar with. Bi is more commonly used for two, like a bicycle has two wheels. Di is just another way of saying two. Tri, most of you probably know, triangle has three sides. A tricycle has three wheels. That one's common. Tetra means four. That one maybe you aren't as familiar with, but you probably have all heard of the game Tetris. And Tetris deals with blocks, which have four sides to them. So, penta, like a pentagon, has five sides. All the other ones, hexa, maybe you're not as common with. Hepta, probably not either. Octa, you probably know, like an octopus has 8 legs. Deca, meaning 10. A decade is 10 years. So a lot of these are commonly used in our everyday language. Even if you don't know them exactly off the top of your head, they're not that hard to remember. And yeah, so I'd recommend that you remember these or memorize them because they're not going to be given to you. So when it comes to naming the molecular compounds, very simple. We're going to name the elements in the order listed in the formula. Then we're going to use prefixes that indicate the number of each kind of atom. Okay, so we're going to give an example here. We're going to walk through all the steps as we do this. So let's not do that because I don't want to have a bullet point. So here's an example. So let's name this compound. Let's go CH4. Okay. So we're going to name the elements in the order that they are listed in the formula. So we have carbon and hydrogen. We're going to use prefixes that indicate the number of each kind of atom. So for carbon, we only have one. So the prefix for one is mono. And for hydrogen, we have 4. The prefix for 4 is tetra. Okay, so far we have monocarbon, tetrahydrogen. We're going to carry this on to the next slide here. Okay. So we are going to omit the prefix mono when the formula contains only one atom of the first element. So if there's mono on the first element, you don't need to have it. Okay, so we're going to get rid of it. So no mono. As for the second element, if there's mono for the second one, you keep that one. Okay, but the first one you don't need. And then the suffix of the name of the second element is going to end in "ide." So rather than carbon tetrahydrogen, we're going to change this ending to "ide." So this becomes carbon tetrahydride. And this would be the name of CH4 for a molecular compound using this naming system. Okay? And that's it. So very simple. Again, you'll probably get the hang of it in like 5 minutes. So, all right. So again, there's some example problems here. I have a video of me going over these, but you can try these on your own. And then if you want to know if you got them right, go watch that video. I'll explain how to do it. Should make more sense to you. As for writing the formulas for these compounds, we're pretty much just going to work backwards, right? So we're going to use the prefixes in the name to tell us the subscript or the little number for each element in the formula. Then we're going to write the symbols for the elements and put the little numbers on them from the prefix. And that's it. Okay, very simple. There's no charges. We're not switching numbers. We're not like +1, -1, and have to figure out how many of each one we have. the prefix in the name literally tells you what it is, right? So here's an example of one. So let's think of phosphorus pentachloride. Okay, so here would be the name, and we need to write the formula. So phosphorus, okay, that's P, pentachloride. So chloride is Cl for chlorine. There's no prefix on the phosphorus, which means there's just one of it, right? Because that would be mono, and we don't write mono. And for chloride, there's penta, so that means there's 5 of them. So Cl5. So phosphorus pentachloride would be PCl5, and that's it. Okay, we're not switching numbers or anything. Super simple. So here's an example of another one. Silicon carbide is a hard material like diamond. Now you'll notice that the name silicon carbide has no prefixes on it. So that means the subscripts for silicon and carbon have to be 1. Now in this one, you'll even notice they didn't even write mono on the carbide, right? Because from the previous rules, it would be silicon monocarbide. That just goes to show that how many times in chemistry when there's a 1, we just completely don't even do anything for it. We just ignore it entirely. So silicon carbide or silicon monocarbide would be completely fine. Personally, I would like you to do silicon monocarbide rather than silicon carbide because there are some compounds that are very common that have mono in the name. So for example, carbon monoxide, right? Carbon monoxide versus just carbon oxide. So, you know, it's good practice to put mono on the second one. I know in this example they don't have it, but you should put mono on the second one, okay? If it's on the first one, you don't put it, but on the second one, you should always put it. It's good practice, and even though they don't have it here, this is not the norm, okay? So don't do that. Put mono on the second one. All right, that's it for this section. That's all there is to it. Super simple, okay? There's some more practice problems here. Again, you can see those in the video I made, but as always, if you have any other questions on this, let me know. You can email me, or you know, you can ask in our Google meeting we have every day, but that's it, okay? So hopefully that helped you, and I will see you in chapter 9.4 on naming acids and bases. All right, bye.